The next section talks about some specific TCP attacks. And the first one they talk about is called a TCP sink or an ACK flood. I think that the diagram in the textbook that shows a sink flood, I'm not so sure that this is actually correct. I think that a more accurate representation would be an attacker sends a sink packet over to the server. The server is going to send a sink packet with an ACK back, and normally what the client's going to do at that point is send an ACK back. Well, if they don't ever send that ACK back, then the session is never fully established. And what you can do is create a whole slew of these half-opened or half-initialized TCP sessions, and you can end up pretty much filling up the buffer, using up all the available space so that you can't establish any legitimate sessions there. I suppose that you can also send ACK packets back and forth instead of data, but the labeling on this indicates that they're not so much talking about ACKs, but they're really talking about sink floods, where you just keep sending out sinks instead of your final ACK request. A sequence number attack is a more sophisticated way to compromise a system, because you're not just trying to do a denial of service. What you're trying to do is insert yourself into an existing session. Like I said, each TCP/IP session is going to have numbered packets within the transmissions. If you happen to get in the middle of a session and you guess the right sequence number, or you get one that's close to the right one, you can either disrupt the session and just make it stop, or you can pick up that session and essentially become the device that had been talking to the server or whatever it is you're trying to get in the middle of. This is done with sequence numbers, which is a little bit different than just a straight old TCP/IP hijack. With the TCP/IP hijack, what you're doing is working with the IP address, not so much the sequence numbers. One is being done at the TCP level, the other is being done at the IP level. The textbook moves on to UDP attacks, and I think it's important to note that a UDP attack involves either the UDP protocol or a maintenance protocol. Now, UDP runs at a higher level than maintenance protocols, but they've grouped these together. UDP normally runs at the transport layer, which is where TCP also runs. Down at the internet layer is where you're going to see your ICMP packets, and that can be a little bit confusing because obviously ICMP is not a UDP protocol, it's completely separate. Anyway, I thought I would point that out because I just thought that was kind of misleading. The discussion on UDP attacks pretty much focuses on pings using ICMP. As I said before, a lot of routers, that's just turned off by default, but if it's left on, then it can be a real denial of service attack. Smurf attacks are a denial of service that specifically target the ping command. And what you do with this is you get a whole bunch of computers that will target a particular source with pings. And so instead of just one box doing it, you might have 30 or 40 boxes, or 3,000 or 4,000, depending on how well orchestrated it is. That kind of wraps up the textbook's discussion on protocol-related attacks. The next section that they discuss here is understanding software exploitation. This is all going to be done at a much higher level than what we've talked about with UDP and ICMP packets. The book discusses right off the bat database exploitation, application exploitation, email exploits. I think email is probably extremely familiar to you. You get emails that tells you something about, please click on this link to verify your information. At that point, if you are unlucky enough to click on it, or maybe lucky isn't the right word, but maybe you're not thinking, you go to some bogus site and you could be infected with the virus, or you could be prompted to enter secure information such as your bank account number or your driver's license number or something. So these are different ways that people can compromise security. Spyware is another category of software exploitation, and this is just really tough to combat. It's so easy to get spyware and malware from websites, and you don't really know until you've clicked on them that they may be a potentially bad site. You know, as soon as you start getting some weird ads for things, that's usually your first clue, but a lot of times at that point the damage is already done. And sometimes it can be really, really hard to get rid of some of this stuff. Just in terms of man hours, a lot of times your best option is to go ahead and just wipe the drive and reinstall. You'll end up with a cleaner system, and it's going to take you a lot less time than trying to find all the registry entries and the files that have been compromised by whatever this malware is. The next type of software they discuss in the book are rootkits. These are almost even worse. Rootkits are usually malicious code, but they're hidden. So you go into Task Manager, you don't see it listed there. You don't see it listed in services, you don't see it really anywhere. One of the hallmarks of this is that it really is difficult to detect. Most of the time with any of these, your first line of defense is to keep up to date with security patches and with antivirus software. But still, a lot of this stuff, especially adware, gets by because it's just hard to detect all of this stuff. I think a real good line of defense is run a couple of different antivirus packages. Don't run them at the same time. You're definitely going to have problems doing that, but have one that maybe you load and you run constantly and it does real-time protection, and then have a couple of others that you can just run as a manually invoked scan occasionally. One of my favorites is Malwarebytes, malware, WAREBYTES.org. They've got a pretty good package. I've been able to get rid of things through that utility that I've not been able to get rid of through other standard antivirus programs. As far as free stuff goes, AVG is pretty good, Avast is good. In a corporate environment, a lot of times you're going to want to go with something that's centrally managed. AVG does have a business edition. A lot of people use McAfee, Trend Micro. I've seen some Panda installations. And I tend to use the Symantec software. One of the big complaints about using antivirus software is that it slows things down. Yep, there's overhead associated with running that. I guess I figure the overhead is worth the ability to catch a lot of this stuff before it actually infects your computer. Continuing our discussion on potential risks, viruses and the more general category of malicious code are just something that you're going to encounter, whether it's a standalone system or whether it's a network system. The discussion here starts with viruses, and in a very generic term, it's just a piece of software that infects your computer. Sometimes the infection is not terrible. It doesn't destroy your hard drive or get rid of programs. I know years ago I was infected with, I forget the name of it, but it was the one that came out on the anniversary of John Lennon's death. What it did was just filled up your screen with a famous quote of his that said, "All I want to do is give peace a chance." And that one was not too hard to get rid of. And in terms of virus infections, I think that was one of the least intrusive ones that I've ever had. That introduction to the virus section talks about all the different types of viruses that there are: polymorphic, stealth, retroviruses, multipartite, armored, companion, phage, and macros. As far as which one does what, I think it's important for you to at least be familiar with those. I'm going to ask you some questions about that, but you don't need to turn into a walking encyclopedia on virus protections. Moving on into this section, there's a header entitled Symptoms of a Virus Infection. I think this is pretty self-explanatory. Most of the time what you're going to see is slower response and just strange stuff happening on your computer. And that's the time when you need to break out your virus scanners, and if you suspect a virus, use at least 2 or 3 different scanning products. They all work differently, they're looking for different things. Something that might not be detected by one can be detected by another. Like I said, Malwarebytes tends to find things that other software doesn't find. So find something that seems to work and then just make sure you've got that handy. A lot of times I keep a CD or a flash drive or an external drive that has a bunch of utilities on it. And that's kind of helpful, especially if the machine is so messed up that you can't get on the internet. At least you've got a way to get some of your utilities onto that box, or at least run them so that you can start doing some diagnostic work. For a brief description of all the different types of viruses that are listed in the book, we'll just go through that real quickly. An armored virus kind of hides itself. It makes it harder to detect. It says that armored viruses cover themselves with protective code that stops debuggers or disassemblers from examining critical elements of the virus. These are kind of hard, obviously they're hard to find. They take more time to write because part of what you're trying to do is malicious stuff, and then part of what the coder is trying to do is hide it. Even though this is all bad stuff, there actually needs to be some skill when you're programming some of these things. Companion viruses attach themselves to legitimate programs, and sometimes you'll see this when you load an exe file, I don't know, like winword.exe. It gets loaded into memory, but if you've got an infected version of the file, what's going to happen is the virus is going to kind of tag along with that. It's going to load into memory at that time, and that's how the virus actually gets started. Macroviruses, I guess they still exist. They used to be just terrible because that was a new exploit and people didn't really know how to disable viruses or have security settings. You don't tend to see that in applications so much anymore, even though I'm sure they're still around. A multi-part type virus is going to do a bunch of different things. It might try and wipe out your boot sector. It might affect all of your EXEs or all your COM files or your DLLs or your batch files. It might mess with your file system. It might delete files based on a certain date or based on a certain time. It's kind of a shotgun approach to really messing up somebody's system. Again, when you get to something like this, I think the best thing to do is wipe the drive and then reinstall. You know, a lot of times people will back up to an external drive, and if they get a virus, then they'll reinstall and then copy everything from that external drive back on there. For some reason, they think that if it was copied to another drive, it for some reason is magically protected and has no virus on it. You have to be doubly careful when you've got data like that that's been backed up. You don't know when this stuff got infected. You could have gone through all that work and then you're just going to reload the virus and run into the same thing. If you are restoring data from a backup, make sure that's all you restore. Don't take stuff from program files or don't take executables. Get those from the original source. Get those from your CD or, grab your download or whatever you need to do there. Because most of the viruses are going to be in program code. They're not going to be so much found in your Word documents or in your MP3 files. Even though, of course, they can be located anywhere, but if really all it is data that you're restoring, go ahead and scan that with a couple different virus scanners and then restore it. You're at a lot lower exposure if you go through that route. Polymorphic virus will change forms. These things can take on a life of their own. Depending on the longevity, depending on all sorts of different things, it'll load, and then at different times, maybe 15 minutes into its life cycle, it'll change itself so that whatever may have detected it in the first 15 minutes will no longer detect it in the next 30 minutes. Those are really hard to get rid of as well. A retrovirus is kind of nasty because, well, all these are nasty, but what it does is it monkeys around with your antivirus software. You might think you've got a virus, but it has compromised your AV software so that you do a scan and nothing comes up. It'll go find whatever the most common antivirus programs are. If they're loaded on your computer, it affects all of those. Let's see. The last kind they've got here is a stealth virus, and a lot of times you'll find those in a boot sector. It does say sometimes that it might infect a file and then the byte size will change, but it goes back into the file system and changes that so that you don't have an issue with some mismatch in the file sizes, because that's how some antivirus programs work, is they actually keep track of file sizes. If there's a change in that, then it might notify you that there's potential viral activity.